Hey friends, welcome to Untitled Coder. In this video, we are going to look at a very new technique that Hugging Face, the natural language processing company Hugging Face has put forward, which is called zero shot classification. So the good thing that they have done actually is that the zero shot classification is now, the model is now available as part of Transformers package that they have already made it available. So first of all, in machine learning, what is zero shot learning? So you can have a look at this blog post for the detailed information about what is happening behind the scenes of how they actually managed to build this particular model. But to give you in a nutshell, first of all, zero shot learning in the sense you train a machine learning model for a particular task, but you expose it or you try to do inference with a different task. So for example, if you have built a machine learning model with a particular set of labeled data and then you have trained using that, but if you are using that model to classify or find out something that is not given in the label data, and that is what is usually called as a zero shot learning. So you can learn more about what is zero shot learning here. So zero shot learning has recently picked up in NLP, especially if you see the reference paper, the GPT-2 paper that they have given. So you can read about all these details on this blog post. So that is zero shot learning. So what we are doing here is, so they have taken the same approach, zero shot learning approach, and then they have used it for a text classification. So the way this text classification particularly works is based on a technique called NLI, natural language inference. So you can say classification as natural language inference. So what they're primarily trying to do is they're primarily trying to set up a premise and a hypothesis. So you can see this example. So this is the premise. Who are you going to vote for in 2020? That is a premise. And then the hypothesis is this text is about politics. So if these two are related, and then you would get a score, which means now the model, all that the model is trying to do is it's trying to determine whether this hypothesis is true or false given the premise. So that's what it is trying to do. So that is what we are going to see in actual practical scenario using a Google Colab notebook, how to run this model. So the first thing is, why do you want to use it? So the most important thing is, it's a state of the art machine learning technique, NLP model, that you can use for text classification. So in a lot of different business cases, you may not have enough training data to create your own text classification model. For example, your business could be just starting, or your company is in a space where you have never had labeled data, training data. So those are the places where you can just right away start using this thing, and then that is the beauty of the zero shot classification pipeline that Transformers package is giving. So let's start executing it. This is a warning that you would get to say that this was created by Joe from Hugging Face. Do you want to really do this thing? So it's okay, let's run anyways. Or you can copy the notebook and you can start it from scratch. We'll link this notebook just below the like button. If you like this video, please like it, and if you enjoy this channel, please subscribe and share the word with your friends. It will be a really great help. So now that the package is getting installed, it's done, it's got installed. So now let's load from Transformers, let's load the pipeline. So it's loading. So like we just discussed, basically what we are trying to do is we are trying to take a text, and we do not have any training data at all. So we don't have any training data at all at this moment. And then we are going to see how this zero shot classification model, which internally uses different methodology that we just discussed about, the NLI, natural language inference, and you can read this detailed article about how it works. What if you have some annotated data, what if you have no annotated data, all those things you can actually read about here. And they've also built a web application where you can go and check the live demo, which is not what we're going to see now, but you can do all those things. So going back, it is still downloading the model, the pre-trained model, and you can see what kind of question. So the sequence is given as who are you voting for in 2020, and these are the candidate labels. So the important thing that you have to understand is, like what we saw here is that you have a hypothesis. But if you see this example, you have a sequence which is your premise, and you have the hypothesis here, but you have candidate labels. That's called candidate labels, right? So what basically happens is, if you see down in the notebook, you would see that the hypothesis template is usually defined like this. This example is, so which means when you see the sequence and when you see candidate label, so it is basically what this model is trying to do is, it's trying to say who are you voting for in 2020. That is your premise. So let me just try to add, my premise is who are you trying to vote, and then okay, so and it is going to create three different hypotheses. Hypothesis 1 is equal to, this example is politics. Second, this example is public health. And third, this example is economics. So now what this model is ideally going to do is, it's going to do a sequence pair. So it's going to take this premise and see whether this hypothesis, when you apply this hypothesis for this premise, does it relate true or false, what's the score. So it's going to take the second hypothesis and then the premise, and it's going to take this third hypothesis and then it's going to do premise. So basically when doing this, it's going to get the score and it's going to present it to you. So that's what it is basically doing in a very abstractive explanation. But you should definitely read this blog. It's mostly in English, not so technical, so you can understand most of this thing and understand what is going on, what is happening behind the scenes. So having said that, let's delete this cell and then let's get to work. So it says who are you voting for in 2020, politics, public health, economics, and you can just run this and see what is the output that you're getting. So by default this classifier is taking that you are looking for a single class, like you have only one class that you want to predict. It's not going to think it is a multi-class, whatever it is. So first you can see that who are you voting for in 2020, and it is saying you have given three options: politics, public health, economics. These are the labels, and then the scores that you see that it says 0.97 is assigned to politics, 0.01 is assigned to economics, 0.01 is assigned to public health. So in this language, if you have to say, so this model is thinking that this premise is more suitable for this hypothesis, which is this example is politics. Okay, so now this is the example that they've given, but our idea is, let's say I'm running a business and my customer is talking about something, which is to say that your app sucks, or let's say your customer service is very bad and I am going to leave the company. Let's say something like that, and let's give customer service and let's say public health and economics. So basically now you might think that there is a word customer service in that, but still let's run this example and see how closely it is related. You can see 99% it is related. So now let's try to say that your customer service is bad. Now let's remove customer service and say your service is bad, I'm going to leave the company. Still you still see that 97% it is related to customer service. Now let us write something else. So maybe let's say you are a company, the food delivery took so long and I don't know if I would order again. So now you can say this is related to delivery, or you can say this is delivered to food quality and this is delivered related to taste. And you can see now so you can see 85% is related to delivery and 0.3 is related to quality. So basically the idea is I wanted to highlight that you can actually use it with any text for which you don't need training data at all. And you can see that this is simply 3 lines of Python code, or probably like 4 lines of Python code, including installing the package, and you have the state of the art SOTA, so to say state of the art NLP text classification model in hand, and you can use it for anything. For example, let's try one last time. Last night the match was really awesome and I'm happy my team won. Okay, so let's say this is related to politics, and let's say this is related to education, and let's say this is related to sports. Let's see what the machine learning model says. So it says it is 0.797% related to sports, 0.01% related to politics, and 0.009% related to education. So we'll do one final test before we move on. So we'll say last night my queen was killed by the pawn and I am sad. So let's say this is politics, and this is education, and this is chess. So let's see what it says. It says 48% politics, 42% chess. So you can actually see that it has the ability to see that this is also related to chess as much as it is related to politics. So if you have added more cues related to chess, then you would probably see that it is actually related to chess. So this is really a good opportunity for anyone who wants to build a text classification model without any annotated data for your business. But the point is, you cannot apply it for every business context, so that is something that you have to understand. But most of the text classification that a company wants is probably, let's say, customer service department, a marketing department, or for social media analytics, which is something that you can very easily do with this current pipeline, zero shot pipeline. So the next thing, as you can see in the notebook, is you just add an argument, and that argument would say this is a multi-class. So which means the model is not going to try to give only one score, which is, you can see that it counts to 100, but it can have multiple scores. That's what this point is. So the beauty of this is you can also use this for sentiment classification. So until what we saw is a normal text classification, where you have got a bunch of labels or classes, and you are trying to align or classify this particular text for some of these classes, like in this case it's like politics or public health or economics or elections, whatever it is. But the beauty is you can also use it for sentiment classification, once again without any annotated data. So how do you do that? You can use it right out of the box, just like this. So when you run this thing, I hated this movie, the acting sucked. So you can see that 0.99, I hated this movie, acting sucked. Or also we can do one more thing, but first, before we move on to that thing, let's just make a very small change to this and then see how does it behave. So we can say that you can also do sequences. So it's not like you have to give only one sequence. We can give sequences. I can say that I am not so happy, which is negation, which is what a lot of out of box, not the machine learning model based, but a lot of lexicon based sentiment analysis tools would break in this case. So we are using actually negation. I'm not so happy, and this is okay. I'm just going to say I'm not so happy, and I'm leaving the job. Okay, that is one thing. And then the second thing I'm going to say is life is beautiful, but it sucks. Okay, so don't think I'm depressed just because seeing this comment, but you can actually see I hated this movie. Oh, okay, it's still executing the same thing. Sequences, I forgot to give sequences. And when you execute it, so it says that the first sentence, I'm not so happy, I'm leaving the job. You can see negative is 99 and life is beautiful, but it sucks. It still understands that it is negative, and then the negative is 0.98, so it works well. So what you saw is until now we saw that the hypothesis, the label that you give is translated into a hypothesis, and that hypothesis template is usually this example is, and then the class name, the label that you have given. But what you can actually do is you can also change that label template, so that you get better outputs, and that's what the example that they have given here. So where instead of just using the default hypothesis template, you can say, you can actually tell the model that I'm looking for sentiment, because when you give this as the hypothesis, like in this case, so the model is trying to link this premise with this hypothesis, and it will understand that whatever positive or negative that we are talking about is actually sentiment, not something else. It could be like blood group, right? So it could be anything, or it could be electric current or whatever it is. But then because you explicitly say that sentiment in the sentence, so the model would have this understanding that you are actually talking about sentiment, not about any random positive or negative thing. And then this has better accuracy than this, as you can see, and that is the main point. So if you want to take it to your own business context, so what you have to play with is not maybe not the training data that you want to do, but maybe you want to have your own annotated data also, but that's not what I'm saying. But this entire video I wanted to make is on the premise that you do not have any annotated data at all. So the only thing that you want to now do is you have to add business context here. So this example actually shows it for a sentiment analysis, so how you can do it, but you can actually do it for any business context. So now you can say that my queen was killed and the pawn by the pawn, and I'm sad. So you can now take this hypothesis template, and then you can say this the game the game is, and you can say polo, and you can say let's say cricket, and if you give this sentiment, now you can see that chess is 61%. So without this template, you wouldn't probably see necessarily the same like 0.61, but when you give this okay, so in this case it's not actually changing a lot, but giving the sentiment sorry, I have not given hypothesis template. Let me do one thing. Okay, so this is 0.61, and I'm going to say hypothesis template is equal to hypothesis. Okay, Collab is making me type the entire thing. I'm not going to do that. So when you execute this thing, so you can see chess is 82%. So earlier it was 61%, but it is 82%. So this is how you can use hypothesis template to give additional context to what you're trying to classify, and this does a wonderful job. And the fact that this is free and this is already available, and this is just a bunch of Python code which could be easily productionized, and also that you do not need any annotated data, and you don't really need a lot of machine learning knowledge also to do this. It's really amazing. So I would like to give my huge thanks to Hugging Face for making this and making it open source, and then for Joe Joe Davison to put together a very beautiful blog in English, which is easily understandable for someone who is not so great in deep learning or natural language processing also. So you should definitely try this out. I'm going to link both of these in the description. If you have any question, please let me know in the comment section. Otherwise, this is a wonderful package. You should definitely try it out, and please give the videos a thumbs up, and then subscribe if you have not, and then let me know what you feel about this particular package. And once again, thanks to Hugging Face for their contributions to NLP community. See you in the next video, and until that, take care. Bye.